Another video about the book I just put out called Understanding Base-12 Math, How to Draw the Perfect Circle Using Dozenal Geometry. You can buy this book. This video is intended for everybody who's already bought the book. So again, I want to say thank you. And we're just talking about the first chapter where I'm introducing the idea that there is a difference between the bases. So we're going to keep going on that because this is the first hurdle that some people are having just to understand how there actually can be a difference. So we're talking about the fact that we're going to be creating a geometric pattern that divides the circle into 360 degrees, and we're going to be using a length of measure that is 0.5 root 2 in base 12. So that's not 0.5 root 2 in base 10, but when we draw the geometric pattern on a piece of graph paper, it's hard to tell the difference between base 12 and base 10. What's the difference? So here you can see some graph paper just with some dots on it. So what's interesting about this geometry is that all of the points that define the dodecagon that we're talking about are actual lattice points. So those are lattice points. Those are points that are created where the horizontal and vertical lines of the graph paper of the Cartesian plane cross each other. So our dodecagon is built on the actual Cartesian plane, and it's defined by actual lattice points. So that's the first thing to be aware of. So when you connect those points, you get a pattern that looks like this. Okay, so again, it's a dodecagon, and all the sides are equal. So you have all these pictures in your book. I'm just showing this for people, maybe if you're watching this, you haven't got the book yet. So this is what you're introduced to, a geometric pattern. It's a type of dodecagon. You can connect the points on the graph paper to create this pattern. So when you start to see when you start to calculate how long those lengths are, you'll find out that they're all the length of 0.5 root 2. So maybe you go over to your friend's house to show him or her what you're discovering, and you draw the dodecagon and you define the Cartesian plane in a way that you're used to, where I haven't actually drawn the x and y axis, but you have a square that's 20 by 20. You know, 10 by 10 is your length of 1. And your friend says, no, and you explain, no, we're not doing it in base 10, we're doing it in base 12. So it's actually looking like that, where it's a 24 by 24 square. And so now your friend looks at you kind of funny and goes, well, so what, you're just changing lines on the paper? It's very easy to see, and so here I have two. You know, on one side I divided up into base 10, other side base 12. Your friend might look at you and go, well, it's obvious that those two geometric shapes are exactly the same size. If you go start from the center and you count over, it's the length of 13 to both of them. They're precisely the same. This just suddenly darkening certain lines on the graph paper, that's got nothing to do with the base. What are you talking about? You obviously got ripped off by this guy in his book. It doesn't make any sense. It's so clear. It's so obvious. I don't know how I can explain it to you more. Those two dodecagons are the same shape exactly. So I'm saying, no, they're not. And it has to do, again, with the size of the decimal places. So I've used this example in the last video. Two squares that are the same size, but when you divide them up into base 10 or base 12, you have different lengths. So if you draw a length, that's the length of 0.5 on this side, 5 diagonal, 5 little squares, and you draw the same line on this side, those are going to be different lengths, although they both have the length of 0.5 root 2, one in base 10, one in base 12. So the person, I'm having this discussion with somebody right now, and they can't believe that I don't see it, and they're really thinking that I'm somehow just in the delusional that this length is different in base 12 than in base 10. So that's the first hurdle you have to get over. I'm curious, what do you think? Is it, who's right here?